My background is I'm a physicist and I work for NOAA and also something called CERES. I'm an adjunct with the Aerospace Department and the Mechanical Engineering Department.
Okay.
And this semester I'm teaching for general engineering, the engineering school.
projects.
So I've been working on a lot of fluid dynamics, actually, because my PhD is from aerospace engineering
Okay.
in fluid mechanics. So I love fluids, I love fluid mechanics, and it's really a neat field to think about. I had a fluids lab there. We had a wind tunnel. We actually, at one point, there were 3 wind tunnels.
Oh, wow.
We had a very unusual water tunnel and a whole series of fluid experiments of all kinds. These experiments that we could do in the physical fluid modeling lab were very, very interesting. We modeled tornadoes, we modeled flow over mountains, and it was a beautiful laboratory. They're just good things that can be done if you manipulate the wind to your advantage. So learning about the winds and learning about how they interact with objects is super important. And there may be tricks that we still need to learn on making, reducing drag and making things better. So I guess one of the key things is when you have flow interacting with an object, there's a normal pressure. Here in Boulder, it's 820 millibars is standard pressure typically. And then on top of that, if you have wind around an object or if you're trying to measure it outside, you'll end up with a dynamic pressure because of the wind interacting with your port or opening on top of what the ambient pressure is. And these dynamic pressures can be exploited for good, or they can cause errors in the case of aircraft altimeters at airports. So we developed a probe that was designed for eliminating these dynamic pressure errors, and it's used at every general aviation airport in the U.S. My colleague and I have a patent on it. I'd say take a look at cars, automobiles that are designed for high speeds. Take a look at the Ferrari, for instance. Take a look at some of the racetrack cars that are designed for racetrack driving, and see if you can learn something from there. And people, as I say, I think we can still learn how to reduce drag on aircraft. And one, for instance, a golf ball has these little bumps on it. You can ask, why is that? And it turns out that it reduces drag and makes a golf ball much friendlier than a perfectly smooth golf ball. It modifies the boundary layer around the golf ball, and so you can think of ways that you might deliberately roughen your design and make it even more aerodynamic, which sounds counterintuitive, but roughening objects can be a wise thing to do.